Okay, everyone. So when we last left off, we had calculated our mean and our median, which to the naked eye look kind of pretty far apart. And so what we're going to do now is, so that gives us, those are two of our measures of central tendency. So in order to understand how to evaluate these values, right, what are very long trips, what are very short trips, we need to also calculate the size of the sort of the spread of these distributions, okay? So in order to do that, we're actually going to start with the measures that we take around the median, and these are called the quartiles. So I'm going to switch over now to, if you Google quartile and bring up the Wikipedia page, this actually has one of my favorite visual representations of mean and median and the sort of distribution measures around them. So what we're looking at here is the median, and you see that we have Q1, these things called Q1, Q3, and IQR. So Q1 is quartile 1, Q3 is quartile 3. Basically what we're doing is in exactly the same way that the median divides the data set in half, if we divide each of those halves in half, then we get the points that are known as Q1 and Q3. So basically what we want to do is divide our data set into 4 parts of equal size. So to do this, what we're going to do is obviously we've got one with the median here, that's dividing it in half. Then we're going to take the lower half and divide that in half, and the upper half and divide it in half. So to do that, obviously I have 14 rows here, which means that I'm going to take the average in this case, because my midpoint is quote unquote between 2 rows, I'm going to say that Q1, which is the middle of the bottom half of my data, is going to be the average of those 2 values. So I'm going to call Q1 is going to be, and again here I'm going to use the sum just because it's handy, is the sum of these 2, okay, divided by 2. Okay, so I have 304 there. And then for Q3, I'm going to do the same thing with the upper half, right? So again, I'm going to go 1, 2, 3, 4, 5, 6, 7. So it's going to be between these 2, right? And so it's going to be the sum of these 2 also divided by 2, okay? So now I have the position of Q1, Q3, I have my median and my mean, and we'll get back to the mean and what that helps us understand in a few minutes. Now what I want to do is calculate this thing called the IQR, or interquartile range. Now, why does any of this matter? Because the thing about a median is that although what we're seeing here is as though the median and the mean, right, are both, this is a normal distribution, right? So we have our nice little bell curve here. This is showing us the relationship between the mean and the median and these various other measures. So basically what you should understand, what I want you to take away from this is that, and actually there's a better, let's look up median, because I think it's better represented in a different visualization. Again, if we go to our Wikipedia page, it helps to understand, so this is actually a nice visualization as well that demonstrates what these different measures of central tendency do. So here we have a normal, so-called normal distribution. It's symmetrical, okay, or it's this one is roughly symmetrical. And so what you see is you have this peak, and the mean, median, and mode, we're not going to worry about mode, are all relatively close together. You know, if you were to put a mirror down the center line of one of these values, it would be almost the same. It would be almost a mirror image. When we have a skewed data set, okay, when we have, you know, this long tail effect, right, it's very asymmetrical. That's where our median and our mean become more important. That's why our median becomes more important. And if we want to understand how extreme a value is, we can't rely on what we call the z-score around the mean. We need to rely on this interquartile range and this range around it that helps us understand how extreme a given value is. So switching back to here, or rather looking back here, again, this isn't quite as representative, or it isn't as demonstrative. What it does is it does tell us how this measure of Q1 minus 1.5 times IQR, right? It's a mouthful. How it relates to the normal distribution, what percentage of values are going to be within it. And so the issue is that what we're trying to do is we're trying to capture the bulk of values And then what we can evaluate is anything that is beyond that value, right, is going to be, we can appropriately describe as being very low or very high for this data set, right? That's basically what we're trying to do, is figure out where the greatest density of values is so that we can identify correctly when something is extreme or is not extreme. Okay, so that we can be accurate in that assessment. So in doing this, I'm going to first identify the IQR, which is defined, if we look back at our image here, which to me is actually the easiest way to see it. Whoops. Nope, don't need Firefox, pardon me. Is just going to be the difference between Q3 and Q1, okay? So that calculation is straightforward. It's just going to be equals, and it's going to be the higher minus the lower. I can reference those directly, so that's 277. And now I just need to do Q1 minus, so Q1 minus 1.5 times IQR. I didn't begin this with an equal sign, right? So I'm just using this as a label. So I can do exactly that. I can say this equals this value minus, now I need to put this in parentheses so that it does, yes, it's going to give me an error. I need to put this inside the parentheses so that it does the order of operations correctly. So I'm going to say in here 1.5 times, and then I can select this, and there we go. And the value I get is negative 112. Now, obviously, negative 112 seconds is meaningless in the context of our data set. So this is a good reminder that you can end up with values in doing these analysis that don't have any real world relevance, right? Negative time does not apply. However, if I do the upper bound, right, which is going to be this plus 1.3 times IQR, right? So in this case, it's going to be Q3 plus, so again, we're pushing out, we're pushing towards the boundary, so it's going to be Q1 minus and Q3 plus, okay, and in this case 1.5 times, and then again the IQR, and I get 997. Now I start to see some meaning to this, right? Because I could look at the median and say that's the median ride is 411 seconds, okay, that's a few minutes. Is 986 an outlier? Is 883? Well, if we were just sort of doing random heuristics here, we could say, well, that's twice as long as the median ride, perhaps, and that's certainly accurate, but it's not that unusual, and we know that because it's less than our Q3, that it's less than our sort of upper bound here, right, which is 997. What we can then say is we can look at these three data points and go, wow, these are real outliers, right? These are really unusual for this data set. So that's one of the reasons, that's sort of the significance of looking at these things. Now, you'll notice on our image here that we also have these, I think it's the little sigma, and that is standard deviation. So for those of you who have worked with standard deviations before, this might be familiar. For those of you who haven't, don't worry. Again, it's just a way of measuring how far from the mean a particular value is. So next we're going to calculate the standard deviations, which is pretty straightforward. All we have to do is on our data set here, and we're going to do some calculations. So the first thing I'm going to do actually is just give myself some space here. I'm going to create a new column. Okay, so I did a right click there, and I'm going to say insert column, and it's going to automatically do it to the left. You'll notice that this is clever enough to maintain the reference. So if you have a cell, if you have a formula that's referencing something, if you add cells, it will generally move the reference as needed. In this case, it stayed in the same column, but if it had moved over one, it would have retained it, which is helpful. So basically, first we're going to look up the formula for a standard deviation. So I definitely recommend you all read this, but we're just going to look at some basic examples. So it's the standard deviation is the square root of the average of the squared deviations of values from their average values. Whoa. Okay, first things first. What we're going to do is we are going to subtract each value from the mean. Okay, so we're going to square the difference between a particular value and the mean. So we already have the mean, right? We calculated that. It's 584. So now what we're going to do is, and I'm actually going to do a copy, and I'm going to make a version of this, and I'm going to say paste special, and I'm going to choose values. And the reason why I'm doing that is because Right now, this is actually, see there, well, that didn't work actually. Well, when I did that paste value, what it indicates, right, is that although this is showing 584, the value that this cell contains is actually 583.758621, right? Which, as we discussed, is too precise. So what we're going to do is actually we're just going to say, look, it's 584. That's the mean. And again, so one of the tricky things with Excel is that sometimes what you see is not what you get. If I've used formatting to make something appear a certain way, then I might actually be working with a value different that's different than I think it is. Okay, so the first thing I'm going to do is I'm going to say I want this to equal this value minus the mean. Okay, it's negative, that's fine. To copy this formula, right, because I'm just referencing the adjacent cell, I can just copy and I can actually just select all of these rows and hit paste, okay, and it's going to make that calculation. So the only one that's negative actually is, oh no, I'm sorry, tricky thing there. So when I did that, what happened? The first ones that I referenced were A2 and E32, right? That's what's in this cell. Well, I moved one of the columns down and it thinks that I want to move both of them, but I don't, and of course there's no value below here. I want to refer to this specific cell in the second instance, but in the first instance only, I want the first cell reference to move and the second one to stay the same, and this is how I do that. I use a $sign. This is specific to Excel. I think this will do it. Nope. Yeah, so I said it before, so it's column and row. So if I put this next to the E and the 32, what it's going to do is it's going to hold that reference steady. And we'll see this here. So now this one says A2, which is correct. This one says A3, but it's always referring back, and it usually highlights if I do this, right? If I double click it, it's always referring back to that mean. Okay, so now I have the difference between each value and the mean, which is the first part of calculating the standard deviation. And then I need to square those deviations. So I need to multiply each of these by itself. So I'm going to insert another column here, and I'm going to say this equals this times itself. No problem there. Again, I can copy and paste this down the entire way. Starting to get some big numbers in here. But that's okay, because I'm going to insert another row, because what it wants to know now is it says square root of the average. So I'm going to take the average of the squared deviations. It's much easier if we step through these things methodically, right? So I'm going to take the average, which of course is itself the mean. So I'm going to say equals sum, and it's all of these. Yeah, okay. It doesn't like it when I don't put the equals sum of these. Okay, but what's the next step here? Now, but I have to divide it by the number of entries. So I've taken the sum, now I need to divide it also. So it's the sum of that divided by, I still have 29. Okay. So again, I'm not going to round until I have finished my calculations. When I finish my calculations, I can round. And then here I'm going to, so now I've taken the mean, and last thing is to take the square root of that. So one more formula here is going to be equals square root, I guess, well, I will use that. So the square root of that cell there, and then I'm going to round that, which is going to be 521. So in this case, my standard deviation, often abbreviated as SD, is going to be 521. Okay? So now I have all of my measures. There's almost all of my measures. I have one more that I want to do. It's called the z-score. It relates to the mean and the standard deviation. And we'll plot all of this out so you can kind of see it visually as well. But the last step we're going to do then is to try to assess which measure of central tendency and distribution is going to be most appropriate to our data set. So we'll come back in one more minute with that one.